Hey, everybody, welcome back to The Doctor is In, the Controlled Environment Agriculture podcast, where we focus on optimizing the indoor plant environment for crops growing in greenhouses, indoor farms, vertical farms, plant factories, containers, and any other facility where we want to grow plants anytime and anywhere. I'm your host, Dr. Nadia Saba, president of Dr. Greenhouse, and I'm so happy that you could join me today. So, I'm going to continue talking about greenhouses today, following on last week's podcast episode about energy efficiency in greenhouses. Today, I'm going to talk about 6 tips to stay cool in your greenhouse. Summer is coming up, and I know a lot of people are concerned about how they're going to change their operations and maybe even the plants that they're growing and the cultivars in order to sort of beat the heat as summer approaches. So I thought I would take today's podcast to talk about what we can do in terms of HVAC and our systems in order to keep your plants and your greenhouse cool. Okay, so number one is shading. One of the first things that we can do to help block the amount of heat that comes into the greenhouse is by adding some sort of shading system to it. By shading the greenhouse, we can block the amount of solar radiation and solar heat gain that comes into the greenhouse by anywhere from 10% to 100%, depending on what type of shading system we use. A lot of people don't realize that solar radiation accounts for 65 to 90% of the total heat gain in the greenhouse. So if we can reduce how much sunlight comes in, then we can reduce how much heat gain comes in from the sun. I know a lot of growers are sort of hesitant about using shading because we're trying to maximize the amount of light that reaches our plants. That's one of the great things about growing crops in a greenhouse is having access to free sunlight, right, for photosynthesis. And so usually, we would recommend shading systems as kind of a final line of defense as opposed to a first line of defense. Unless you are in a particularly sunny location, then you're probably going to need it no matter what. So, the benefits of using shading systems is that it protects your crops from direct sunlight and heat stress. It can help reduce the water demands by your plants, right? Because when they're stressed, they're going to want to drink more water, just like we humans do when we're out for a hike or out in the desert. We want more water, and so do plants. And it can also help reduce the cooling requirements, right? Regardless of what type of system you're using to cool, whether it's, ventilation or evaporative cooling or mechanical cooling. By reducing how much heat comes into the greenhouse, we can reduce the demands on those cooling systems. Now, there are multiple ways that we can shade the greenhouse, right? We can have a shade screen sitting outside of the greenhouse that might act like a canopy of shade over the top of the greenhouse, and that blocks solar heat gain from ever entering the greenhouse. The challenges with an external shading system is that it's susceptible to wind and weather, and we would probably want to remove it in the winter because in the winter, we definitely want to capture as much sunlight as possible. So, there's some maintenance requirements, and if it's outside, it's usually stationary. And so, you're living with that no matter what, even on a cloudy summer day. The other source, the second type of shading system is an internal shade screen, right? And so now maybe solar heat gain and sunlight can enter the greenhouse, but if we have this shade sitting over the top of the canopy, usually maybe about gutter height, it can block heat gain into the canopy zone, even though it's coming into the greenhouse. Internal shade screens are more mobile. They're easier to move and to control with automated systems, with automation than maybe their external counterparts. It does require more coordination with the other stuff that's hanging inside the greenhouse, such as your lights and HAF fans. And if you have an internal shade screen, you kind of create sort of two internal zones in the greenhouse, right? One that's the canopy zone that's below the shade screen, and one that is sort of the roof zone that's above the shade screen. And so in that case, it really works best if you have ridge vents or roof vents that you can open and release some of that heat that builds up in that sort of greenhouse attic space, and just kind of let it leave and escape through those vents to the outside. The third type of shading system that you might consider is a coating, is actually putting like a whitewash, a reflective coating on the outside of your greenhouse glazing. Now, this whitewash helps to reflect sunlight, and it also blocks solar radiation from entering the greenhouse. There are different coatings that can be applied to most glazing materials, regardless of whether you're using glass or plastic. Um, you know, a advantage and disadvantage is that it's temporary. So it will degrade over time, its effect, and it will wash off in the rain. So if you're somewhere that rains in the summer, you might have to reapply it after a rain. And so, but that can be also a good thing, because as fall comes around, you don't want that coating anymore because you want to allow as much light in as possible. And so then it will wash off naturally in the rain. And if it doesn't, then you will need to remove it yourself by spraying down that coating. The other advantage of these coatings is that it helps to create diffuse light, right? Again, we don't have that direct solar radiation or beams of light hitting any of the plants. It requires less infrastructure, right? You don't need an automated system. You don't need a high wire system. You literally just paint it or spray it on, but it will always be there until it gets washed off or degrades. Okay, so those are shading systems. I am a big fan of shading. And depending on what type of crop you are growing, you might want to let in more or less light in the summer. If you're growing a high DLI crop like tomatoes or peppers or cannabis, then you might want a shade screen that's, 20 or 30 or 40% reflective. Where if you're growing lettuce, and you have a DLI of maybe 15, then you could probably go with a higher shading reflective value of something like 50 or even 70%, depending on where you're located. So there's a lot of options out there, and I really encourage you to use them in those summer months if heat is a big challenge for you. Okay, so the second method or strategy or tip for staying cool in the greenhouse is just good old ventilation, right? Opening up the windows, turning on the fans, just releasing the heat that builds up in the greenhouse and exchanging it for outside air that is, either the same temperature or cooler than your target temperature. There are two typical methods for achieving ventilation, for exchanging that air between the inside and outside, and that's natural ventilation and mechanical ventilation. Natural ventilation means that we're using the natural physics and forces of the environment and sort of going with the flow when we are ventilating and exchanging air with the outside. Natural ventilation tends to be driven by two predominant forces. One is wind, which is external to the greenhouse, and the second is buoyancy, or the chimney effect, which is internal to the greenhouse. With wind, what we're really doing is we're kind of relying, right? It's almost like nature's fan, and we're relying on that wind to push into the greenhouse the cooler air from the outside, and then push it out the hotter air back to the outside. With wind, your location matters a lot, right? As well as the orientation of your greenhouse. We look at a lot of greenhouses that, might be oriented for sunlight, right? And south facing, but aren't really considering where the predominant wind directions or winds are coming from. And if you have a naturally ventilated greenhouse, maybe the wind direction is as or more important than even the sun orientation to your greenhouse. It really just, again, depends on what you're growing and where you're located. But if you can orient your vents, either in the roof or in your sidewalls, to capture that wind coming from the west or coming from the north or whatever your predominant wind direction is, then we can rely more on that wind to help exchange the air. Wind-driven natural ventilation is most effective with narrow greenhouses, right, as opposed to big gutter-connected Venlo-style greenhouses. Wind will help to relieve that heat that's sitting up in the roof attic. Like if you have that shading system, wind can help pull that hot air out. But if you're relying on the wind to move air down into the canopy, really, big, tall greenhouses and wide span greenhouses aren't going to be that effective. It's going to be more effective with your short, narrow greenhouses to bring that wind down into your canopy. Also, having a combination of both ridge vents and wall vents can help facilitate more airflow, more volume of air into your greenhouse. The second method of natural ventilation is buoyancy. With buoyancy, hot air rises, right? And as the solar heat gain heats up your greenhouse, that temperature becomes hot and that hot air rises into the attic, and that air is going to want to continue moving upward. So if you have ridge vents in your greenhouse, then that hot air can then escape to the outside air. Now, the thing with buoyancy is that it relies on the second law of thermodynamics, which means that hot air, right, heat moves from a position of higher temperature to a position of lower temperature, or higher energy to lower energy. So if it's outside, it's say 50 degrees and you're in maybe the spring or fall or even the winter, and it's 50 or 60 degrees outside, and you're targeting a greenhouse temperature of 75 degrees, well, that heat, right, inside the greenhouse is naturally going to want to flow to the cooler outside. That makes perfect sense. But now all of a sudden, if it's the summer, and if you're somewhere hot like Sacramento, California, where we are, or Tucson, or Florida, or anywhere that gets above your greenhouse target temperature, then that hot air isn't going to want to move to the outside. And in fact, the outside air is going to want to move to the inside because it's cooler. But again, if we have those shading systems and we have hotter air in that attic space, then we can still relieve that hot air from the greenhouse, from the top of the greenhouse to the outside, because sometimes that heat builds up so much. It could be 120 or 130. I've even seen some growers hit 160 degrees in that attic space. Well, even if it's 100 degrees outside, right, that's still a 20 or 60 degree delta. And that hot air is going to naturally want to move out of those roof vents, out of the greenhouse into the outside. So it can still be an effective way to relieve the heat building up in the greenhouse, especially if you're using that shading system and you have that hot zone above it. Okay, the other method of ventilation that I'm sure many of you are familiar with is mechanical ventilation. And just like it sounds, it's mechanical, which uses fans, right? We are relying now on fans to move air in and out of the greenhouse. These fans are typically, right, for a traditional greenhouse, are exhaust fans that are pulling air from the outside into the greenhouse from the opposite end of where the fans are, and then pulls that air across the greenhouse and then out the exhaust fans. And the other method is to have supply fans, right? Where now we are pulling air from the same side of the greenhouse that we're pushing it into the greenhouse, and on the opposite end we have openings or louvers or dampers that then relieve the air that we're pushing into the greenhouse. With fans, one of the really nice things about mechanical ventilation is that it is predictable, right? If we're relying on natural ventilation, whether that's buoyancy or whether that's wind, we are 100% reliant on what's happening outside, right? Is it a windy day or a calm day? Is it a hot day or a cool day? And how is air going to move in and out of the greenhouse based on those outside weather conditions? With mechanical ventilation and fans, we get to decide how much air we want to move in a very predictable way, right? So we can size our exhaust fans for 40 air changes per hour or 60 air changes per hour, depending on what we're trying to accomplish. With supply fans, we can connect it to maybe a ducted system, right? And push the air across from one end to the other end of the greenhouse, and not only predict the volume of air that we're pushing into the greenhouse and control that, but also manage the airflow around the plant. So mechanical ventilation, for us as HVAC engineers, is much easier to calculate the amount of air that we need on any given day under any different conditions, including how big your plants are, or whether it's going to be a hot, dry summer day or a hot, humid summer day. We can say, look, this is the amount of volume of air that you need to push through this greenhouse in order to relieve the heat and humidity. And we can specifically size the fans for that ventilation rate. And if you have a good control system, we can also help automate, right? And create that sequence of operations where if the temperature is, X outside, maybe, if it's cooler outside, then maybe you only need to turn on one fan, or you only need to ramp it up to 20% of its maximum capacity. And on a really hot day, you might need all the fans on running at 95% capacity, right? So mechanical ventilation is much easier to control what it is we're trying to achieve, which is exchanging the hot, humid air from the greenhouse with cooler, dry air from the outside. Okay, so number 3, while we're talking about ventilation and exchanging air, let's talk next about evaporative cooling. I think many of you are familiar who are listening to this podcast with evaporative cooling systems. Usually we think of pad and fan, right, where we have a wet wall at one end of the greenhouse and we have exhaust fans pulling that hot or dry air from the outside across that cooling pad and then across the length of the greenhouse and then out the exhaust fans. Some hybrid greenhouses now and positive pressure greenhouses might still have that wet wall at one end, but now the fans are at the same end, and there might be a plenum in front of it that then pushes that evaporatively cooled air through ducts or through supply fans and towards the other end of the greenhouse. In addition to pad and fan systems, there's also high pressure fog cooling and low pressure misting systems. We don't usually recommend low pressure misting because those water droplets are so large that they might not evaporate effectively or quickly enough to get that evaporative cooling effect before those water droplets land on your plant. So instead, we like high pressure fog systems, which are 1200 to 1500 psi. And produce very fine droplets of water that easily evaporate. There are challenges and benefits associated with both of these. With pad and fan systems, all of the water that's delivered to that cooling pad is going to be evaporated before it enters the greenhouse. You're never going to have a mist of water that enters the greenhouse that could land on your plants and other surfaces inside the greenhouse. But of course, one of the biggest downsides is that we have a gradient of temperature and humidity from one end of the greenhouse to the other, right? I mean, we might see that entering the greenhouse through the cooling pad is 70 or 75 degrees, and by the time it reaches the other end of the greenhouse could be 80 or 85 or 90 degrees, depending on the length of your greenhouse and how big your crops are and how much they're transpiring and whether you have a shade system. But we have a gradient, right? And so that's not always ideal, especially if you're trying to grow the same crop within the greenhouse. Now, if you have the option of growing maybe a cooler cultivar or a cooler strain or a cooler crop near the cooling pad and a more heat tolerant crop or strain at the opposite end near the exhaust fans, then you can go with that gradient, right? You don't have to necessarily be working against it. You could be working with it if you know what to expect. So that is typically one of the biggest downsides. We also don't recommend having greenhouses that are longer than 100 or 120 feet, maybe 150 feet long, because beyond that, you're not really going to have much of a cooling effect at all on the other end of the greenhouse. The other method of evaporative cooling that people are interested in is high pressure fog cooling. One of the perceived benefits of high pressure fog is that you could have these nozzles, right, delivering this fine mist of water everywhere in the greenhouse, right? It's not just at one end of the greenhouse, it's not just, along the perimeter walls, but we could have them internal. But the challenge is that we are now relying on the air inside the greenhouse to be the source of heat that then evaporates the water. Well, if we're hitting our targets, right, if we have a temperature of 80 degrees and a relative humidity of 65% relative humidity, the power to evaporate water is much less than it is if it's outside is 90 degrees and 20% relative humidity, right? That air really wants to evaporate water, but your target temperature inside the greenhouse is not readily available to evaporate that water. So you actually could have a lot of ups and downs and cycling of conditions, because if you miss too quickly, then you're not going to evaporate water and that water is going to land on your plants. But if you wait too long, right, for the greenhouse to warm up to 90 degrees and drop to 30% relative humidity, then you're outside of your target, right? And so finding the balance of frequency, duration, location of your fog nozzles is a real science and somewhat of an art that I spent half of my PhD dissertation studying. And it is not for the faint of heart, but it is an interesting prospect for those of you who are interested. So number 4, and I don't want to miss out on this one, because I do think that it is underappreciated, the value of cooling and the value of managing crop stress in the greenhouse is air movement. Simply by moving air across our plants can help to cool our plants, right? We have this effect of transpiration, right, of plants pulling water up from the root zone through the shoot and out the leaves, and then evaporating into the air, just like the evaporative cooling that we're getting from our pad and fan and fogging systems. We're also evaporatively cooling, or the plants are evaporatively cooling themselves when that liquid water reaches the stomata of the leaves. When that water evaporates, it effectively evaporatively cools that leaf. And so anything we can do to facilitate that evapotranspiration process in the plant is going to help keep your plant cool, regardless of what the temperature and humidity is around the plant, right? I mean, yes, we use the air as a proxy to manage our plants, but it's really the plant that we are trying to manage and its processes. So by blowing air across these plants, we break the boundary layer that develops around the surfaces of these leaves. Essentially, when that water droplet is sitting in the stomata, it is at 100% relative humidity, right? It is at saturation. It is liquid water. And so if there's nothing to sort of bring some fresh air into that space around the stomata and break up the boundary layer, which is like a little bubble, little pocket that forms around the leaf, then that liquid water that transpired to the leaf is just going to stay liquid. So by moving air across the leaf, we break up that boundary layer, we bring in some air that is not at saturation, and we allow that water to evaporate away from the leaf. Now, something to note about it facilitating this evapotranspiration process as a way to evaporatively cool the plant is that your plants are going to require more water, right? Because they are going to be transpiring and evaporating more water. That's exactly the effect we're getting, which means that we need to make sure that the plant has all the water it needs to continue that process. So you might, if you're doing drip irrigation, you might have to irrigate more frequently if you're blowing more air across the plant. I think for growers who have been using maybe some of those underbench ducting systems or even overhead ducting systems that air is blowing directly onto the plants, I hope many of you have realized, and if you haven't, pay attention and notice and let me know if this is true or not. But those plants probably use more water because they're evaporating more water. So pay attention if your plants start wilting under, the previous watering regime that you had, then you might need to increase the frequency or volume of water that you feed to your plants with a drip irrigation system. Now, if you are doing hydroponics and, it's a flow through type of system, NFT or, deep water culture, something like that, then chances are they're going to be fine. But they might still use more water, so you might have to refill your reservoirs and nutrient tanks more frequently because those plants are transpiring. But they will get through those hot days more readily by facilitating evapotranspiration. Sort of related to that is number 5 is root zone management. So, again, having well-watered plants will allow them to push more through transpiration and do more evaporative cooling of themselves. You also will want to keep an eye on your nutrient stock levels, how much nutrients your plants are taking up. If water moves too quickly through the plants, they might leave calcium behind, and you might see some effects of that through leaf tip burn or blossom end rot. So you might need to adjust your nutrient levels to make up for that. But also, something that we don't often think about is that we can, we at Dr. Greenhouse are focused obviously on the aerial environment, right? Managing the temperature and the humidity and the BPD and the airflow, right, around the plants. But there's also the root zone, right? And although we don't talk a lot about the root zone here at Dr. Greenhouse, we can also effectively manage the plant temperature through the roots, right? It's almost like thinking about your feet, right? In the winter, I know that if I can keep my feet warm, the rest of me feels warmer, right? But as soon as my feet are cold, it is so much harder, no matter how hot it is in my house or in my office. I still feel cold, right? Because my feet are cold. I've actually learned this as a trick in the summer that in my car, if I'm in the car and I'm hot, I actually blow the air conditioner down onto my feet and I cool down more quickly than if I blow it at my face or at my body. So, same thing with your plants. If you can keep their feet warm, right? If you can keep their if you can keep their feet cool, and by managing the root zone temperature, usually through the water temperature, or even by having reflective materials around the pots so that they're not absorbing heat through those black pots, then they will effectively stay cooler. And I kind of said keeping their feet warm, but the same is true in the winter. We're not talking about winter greenhouse operations, but the same would be true in the winter. A lot of really experienced growers have learned that delivering warm water to plants under cooler conditions, under winter conditions, can help keep their plants warm and have less cold stress. The last tip, number 6, is photoperiod shifting. Now, for those of you who just don't have the shade systems, just don't have the cooling systems, just are struggling to manage heat in your greenhouse, sort of a last line of defense can be photoperiod shifting. And what that means is rather than using sunlight, right, all the benefits of sunlight during the day, is using your supplemental lighting at night and light depping the greenhouse during the day and 100% blocking solar radiation from coming into the greenhouse and relying on electric lighting. I know this is not ideal. I know this is not why you are growing in a greenhouse, right? We want the sunlight. We want all the benefits of all those spectrums of light, right? That we still are learning about. But sometimes, if you cannot manage your greenhouse temperature something south of 90 degrees, then this is something to consider. It's also not ideal for your staff and for your workday, right? I mean, that means that you might have to work through the night as opposed to during normal operating daylight hours. But if this is how you can manage your crop to continue growing without being super stressed, without overusing water and nutrients, and you have the supplemental lighting, then this can be a strategy for you. We recently did an analysis where we looked at this idea of photoperiod shifting, and we were able to run the electric lightings from like 10 p.m. until, daylight, and then we turn them off. And then during daylight, from say like 6 in the morning to 8 in the morning, we use the natural daylight. So we still are exposing our plants to UV and far red and some of these other spectrums of light that we might not get from LED lights. And then we deprivated. We light depped after that, after 8 a.m. And you guys might be saying 8 a.m., like that seems really early. Well, that was just with the greenhouse systems, with what they had, that's what we could control to. But if you ever look at a sunlight graph, you will see, I mean, it goes from 0 to 1,000 micromoles, or 1,000 watts per square meter in, just a few hours. And then you're sitting at this really high level of incoming solar radiation for 4 to 8 hours during the middle of the day, depending on where you're located. Again, it depends on what systems you have, right? If you have good evaporative cooling systems, if you have good strategies and shading systems, then you might not need to go to this extreme. But this is an option for you to sort of weather the heat during those really tough months of July and August. Okay, so to wrap up, to summarize, the 6 tips that we have for keeping your greenhouse cool are: number 1, shading, which is actually more like a last resort after you do the everything else, so we don't block the light that we're trying to give the plants. But number 1 is shading. Number 2 is ventilation, either natural ventilation with wind and buoyancy or mechanical ventilation using supply or exhaust fans. Number 3 is evaporative cooling with pad and fan systems or high pressure fog systems. Number 4 is air movement across the canopy. Number 5 is root zone management, so managing the temperature of the feet of your plants to keep them cool. And number 6 is shifting the photo period to cooler parts of the day at night or the early morning when you don't have a lot of solar radiation, but of course you're going to need supplemental lighting to hit your DLI, and shifting also your work schedule and your staff's working schedule to keep an eye on all of the systems and your plants. All right, well, I hope you enjoyed today's lesson. I hope you get a lot of great takeaways from this. Anytime you have any questions about how to manage your greenhouse or how to design your greenhouse and what systems to install, please reach out to us. We're here to help you. All right, so have a great day and keep on growing, everyone. Thanks.